Hi, I'm Steve Lee. Thanks for having us here. I'm honored to be joined by three of the great engineers that work on Bitcoin, and we are here to talk about upcoming proposed changes to the Bitcoin protocol, and which are quite technical, but we're going to try to keep it high level and speak to the user benefits from these proposed changes. So first, let's do a quick round of introductions. Let's start with Matt.
Hi, I'm Matt. I've been doing Bitcoin protocol engineering since early 2011. Done everything from Bitcoin Core to some higher level work, but mostly various protocol improvements, both on the mining end and in Bitcoin Core.
Cool. Hey, I'm Lolly. Some of you know me as Roast Beef. I've been working on Bitcoin for about 5 or so years. I primarily focus on Lightning. I've worked on Lightning for like 3 years or so. I kind of focus on development of Lightning, kind of like design, the specification, and I work at Lightning Labs, kind of like one of the implementations that's actually working on Lightning actively today.
Hey everyone, I'm Jeremy. I've been interested in Bitcoin since maybe 2011, involved in the community since 2013, and doing core development since around 2016. And yeah, that's my spiel. Back to you.
Great. So one upcoming potential change to Bitcoin, you probably heard a little bit about it. Schnorr signatures have been talked about for a number of years, and last month a new proposal called Taproot was published. So Matt, could you maybe speak to what that is and what kind of benefits users of Bitcoin might see from this change?
Yeah, right. So the proposal as written currently actually has two related concepts. So the first being Schnorr signatures, which you mentioned, which are really nice. They enable much more efficient multisig. So multisig that doesn't require publishing a whole long list of keys or a whole long list of signatures. It's just one signature. It's all combined together on the chain. This is also better for privacy, right? Because no one sees what your multisig policy is. And then also it has a related concept called Taproot in it, which enables you to kind of hide any more complicated scripts you have. So any more complicated scripts can be much more efficiently run on the chain so that you can have things like Lightning scripts, but on the chain it just looks like one signature, one regular one-of-one signature, standard pay-to-pub key. And that's great for privacy because you can hide this. It's also great for efficiency. Obviously, you don't have to publish all of this crap. You don't have to put it on the chain.
Yeah, and I guess Schnorr is also really good for Lightning because it actually makes it more private. Right now, whenever Lightning payment is sent, it kind of has like the same identifier in the entire route, so you can kind of distinguish it. While if you have like Schnorr on top of it, you can actually randomize the identifier every single hop, so it kind of like adds more privacy to Lightning itself. And we already kind of like have like plans how to incorporate it in the future, but it's kind of like a really cool update because like as I was saying as well, it actually makes Lightning channel look like regular payments on chain, so you kind of like blend into both aspects of it. Like the biggest thing I think is that in the typical case for smart contracts, if everyone agrees, you basically just sign up on the contract, you can move forward, and that's how you kind of like allow it to kind of like blend with the regular traffic. So kind of like more privacy for all, which is pretty good.
Jeremy, maybe you can speak a little bit more to Taproot. What kind of, because today with Bitcoin scripts, if you have a lot of different spending options for coins, all of that information gets published to the blockchain, so it becomes infeasible. Can you speak to some of the potential innovations that might be possible with Taproot?
Yeah, so one of the nice things about Taproot is there's always this n of n opt-out path. So you could have a really, really complicated script that, let's say it's a kilobyte or 10 kilobytes of data, and then if you can publish a valid spending path for that and you can get everyone to agree, you can just sign off directly, which should help with both privacy and scalability of the scripts. Not only that, because Taproot has better paths for upgrading the opcodes in Bitcoin script, it's going to make it easier to add some other things that are going to help with scalability, namely the stuff I've been working on, which is op secure the bag.
We'll talk about it in a little bit. What about what can a wallet do, like to improve custody solutions when you can have multiple scripts? Like, can you give an example of like backup options to, in case you lose your primary key?
Oh yes, one example, you can have a situation where like maybe I lost like my primary key, then I have like another key that's kind of like in the path itself, where I can move after a particular like delay of like a CSV, right? So you can say, okay, if I lose my main key, maybe within like 2 weeks, I can actually like have another key that I can use to move my funds along. I guess the good thing about that too is you can kind of like have more complex multi-sig, as Matt was saying. So you can kind of like have maybe like a 100 of 200 multi-sig. And the great thing about that is that like if you had to have that on chain, it would be a very, very large transaction on chain because maybe it would be kilobytes in size. While if you have like Taproot, you can kind of like only reveal exactly which of those paths you actually want to do. You can also actually do threshold signatures, or kind of like an M of an N, only using one of the keys. So really allows kind of like a lot more flexible access control policy for your own coin, which is big for custody. I think exchanges will actually also really like this, and maybe we can also have other cool use cases as far as like hybrid kind of like two-factor wallets as well. Yeah.
Right, and if you use that, especially if you're an exchange right now, a big problem is it's very identifiable. A lot of exchanges have unique multi-sig policies, and so you can identify their hot wallets, their cold wallets on-chain. You can see how your competitors are doing if you're another exchange. Yeah. And with Taproot, you can still have all those policies, but because you don't use them in the common case, you don't actually have to expose that on chain, and even if you do expose, you don't have to expose it until afterwards, so after the fact, which gives you really nice privacy benefits, even when you're doing much more complicated systems.
Mm-hmm. Yeah, can you maybe go into a little bit more detail about how Taproot can achieve all Bitcoin outputs would be indistinguishable, and as you just mentioned, a majority of spends would also look the same?
Right. So with Taproot, you have kind of a general high-level model of if you build out this complicated script, whatever, and then if everyone involved in that script, right? So let's say you have a 4 or 5 multi-sig or something. Well, if all 5 are online, you can just create one single signature. You can say, okay, look, everyone involved in this has agreed. We don't need to bother with this complicated script. We all agree with what's going on here. And so that becomes a single signature on the chain. Right? And if you actually can't do that for whatever reason, maybe one of the devices actually is online and you want to use your 4 or 5, well, now you have to expose a little bit more information. Maybe you reveal part of that policy, right? It's a nice, you have a Merkle path structure for different policies, right? So you might have 4 of 5 or 3 of 5 or 2 of 5 with different keys and a time lock, whatever it is. You only have to reveal the part that you're actually executing, the part that you're actually using. And of course, in the general case, you don't reveal any of that. You just have a single signature. And no one learns anything aside from everyone involved in this agreed, which might just be a 1 of 1. It might be something more complicated, but no one other than you learns anything about it.
Yeah, and I think that's really big because right now, if you're doing kind of anything fancy on Bitcoin, it's pretty identifiable on chain because you're using kind of like a different output, right? And in the future, you could say maybe that like those outputs will become like targeted or they'll be censored. While Taproot, every output looks the same in the kind of like the cooperative case, which is typically how contracts are settled, in real life and then also in the system.
So we haven't spoken too much about Schnorr signatures and some of their properties and maybe differences with the current ECDSA signatures in Bitcoin. I've heard a little bit about tweaking a signature and summing together signatures with Schnorr. So can someone say, like, or maybe describe an application of tweaking signatures?
Mm-hmm. Should I take it? Or?
Well, I think maybe rather than tweaking, one of the things that's interesting to look at is the ability to aggregate Schnorr signatures together. Right now, in a Bitcoin block, you go and you process every signature independently, and so you have to process n signatures. There's also an ability to cheaply add together signatures and then do a single verification with Schnorr, which will hopefully improve the throughput of a Bitcoin transaction. There's also an ability within a transaction to just do a single signature. And so within a single transaction, you might be able to pare down the number of signatures needed from 1 per input to just 1 for the entire transaction.
Yep. And then another cool thing, you can actually use Schnorr to replace kind of like the concept of like a conditional payment in Lightning. Because right now we basically have like a payment hash, and if you reveal that pre-image, you can kind of like settle those funds. With Schnorr, you can set it up such that like if you have a signature, in order for you to actually create the signature, you must reveal a secret, right? So it's kind of like this atomic exchange of a signature for a secret, which is useful for many other kind of protocols that people have designed, like coin swaps, coin during time stuff. Yeah, a lot of cool use cases there.
And better privacy in Lightning.
Yeah, and better privacy as well, because on-chain just looks like someone just spent a payment and doesn't look like, oh, there was a conditional transfer. And that's just really good because now everything kind of like looks the same, which is good for fungibility as well, because you can't really identify, okay, that was a channel closed, that was like a swap. It's just kind of like, oh, those are Bitcoin transactions, which is what we want to do. It's how we want it to be in the end.
I think conceptually, the core reason why these things work is that Schnorr signatures are essentially linear. So there are ways of adding them together and subtracting parts of them that make sense and give you straightforward equations to work with. Whereas in ECDSA, the signature itself is not really linear. It's divided by one of the factors, and that makes the things kind of unpredictable and not able to be combined in a straightforward fashion.
Yeah, like basically the math works out a lot. It's a lot easier for all the math when you're doing the signatures compared to ECDSA. So it makes it easier to kind of like construct these protocols because it's okay, well that adds to that, I can do that, and then you go from there.
So I think to summarize the Taproot proposal, it was published last month. It's now available for feedback from the community. There's a lot of exciting things about it. These guys have talked about the scaling benefits, privacy and fungibility, and some of the innovation that could be done with this change. Let's switch gears to another proposal that's being discussed, and that's SIGHASH no input, which it kind of sounds like it's in the weeds technically, but Olaoluwa, maybe you can speak to what it could enable and what the benefits would be if this were enabled.
Cool. I'll explain kind of like what a SIGHASH is at a high level. So basically, whenever you sign a Bitcoin transaction, you sign like a SIGHASH. And SIGHASH kind of includes certain fields of the transaction. That basically lets you ensure that, okay, this transaction is only authorized to send to me. I can send 5 Bitcoin. No one can modify it, right? Because someone modifies the transaction, that makes the signature actually invalid. So no input is kind of like a different way to solve malleability in Bitcoin because SEG would solve malleability by saying that, okay, if the signatures change, everything else is still valid. No input is basically saying that, okay, I just want to spend from that, public key or that script itself, which makes things a lot more flexible. So no input was actually proposed maybe like 4 years ago as part of the original Lightning white paper. It was proposed as a way to kind of get around this whole issue to make sure that we can actually construct transactions safely, right? So on Bitcoin, it's kind of a little different from account models because an account model you kind of have like an imperative approach where you're kind of modifying the state on chain, while Bitcoin smart contracts are more kind of like an execution tree in a sense, right? And no input's really cool because probably the biggest thing it allows you kind of to nest these transactions off chain more effectively. So one major use case is something called L2, which is proposed by Christian Decker, Rusty Russell, and I was also a co-author in it. Basically simplifies the backup model around Lightning, right? So right now with Lightning, you have something called it's kind of like a revocation-based model, where if you cheat, you basically get punished, right? Which means you can lose money. But you can kind of accidentally enter that phase and possibly lose money, which is definitely kind of not very safe and kind of a difficult thing to get around. While no input, along with L2, makes it a lot more simple because you can kind of now just basically replace the latest state, right? So rather than saying, okay, if you broadcast a prior state, you lose money, we can kind of accelerate you forward. So no input is generally kind of a very cool, kind of tool in the toolkit to make smart contracts a lot more safe on Bitcoin, and there's many other use cases as well along with it.
Maybe I think the benefits are pretty clear by enabling that. What are some of it hasn't been formally proposed yet, I don't think. Mm-hmm. So can someone speak to maybe some of the challenges that are being debated by developers today?
Yeah, definitely. So so no input, some people think it's maybe a little more dangerous because whenever you have something that's, let's call it SIGHASH all or all inputs, you basically kind of bind to every single input uniquely, and every UTXO kind of has a unique identifier, indexed to the UTXO set. While no input is a little bit more kind of lazy, it's kind of a lazy binding mechanism, it instead just binds to the script itself. So therefore, it can possibly allow for replay, right? If I send coins to maybe your address and then I spend it with no input signature, I can then use that same signature possibly to replay those coins, right? So you can imagine, let's say I send money to an exchange, someone could possibly, if I reuse that output, send the money to an exchange again, then maybe I have to go through some refund flow, right? So it's kind of it's a cool thing because it allows for more powerful behavior, but at the same time we need to be cognizant of the end risk for the user, and so we're trying to take kind of a very principled approach to ensure that we can analyze all the possible attack vectors and mitigate them as much as possible. Because it's kind of you get a lot of great power with no input, but at the same time you need to make sure that people are using it in a responsible manner so they don't lose coins out in the wild.
TLDR, if you use no input, all of a sudden public key reuse in any form goes from a privacy loss to, oh, you're probably going to lose money.
Yeah. So yeah,
Which is a pretty major departure from existing Bitcoin, so it's important that it be opt-in. There's a lot of discussion around how to make it appropriately opt-in, how to make every party to a transaction aware that this becomes an option, or that this is how this transaction is being structured.
Yeah. So ideally, it's only used in smart contract use cases, because otherwise, like Matt was saying, right now, if you reuse an address on Bitcoin, it's like, okay, whatever else, it's privacy. If you reuse an address with no input, you could possibly lose some coins, or maybe have to do some weird refund thing. So it's definitely like a thing where kind of like approach carefully to ensure there's no kind of like catastrophic like DAO-like event in Bitcoin or something like that. So
Great. Any comments, Jeremy?
I think that I'd like to make it maybe a little bit more like high level and approachable. You can kind of think of this as like nuclear launch codes. So when you're using no input, it lets you like say, rather than just like one specific missile, you're like saying any of the missiles, and you maybe lose the granularity of like which one you're actually specifying, which might be kind of dangerous. Like you might be like, oh, we wanted to send this one, that's a regular missile, not this one that's like a nuclear missile, but you gave the code that's going to be able to direct any of the ones that are in your arsenal.
Or
and
really
that kind
all of them.
Yeah, or all of them.
Yeah.
And so that's where people are kind of worried about finding a way to layer on additional restrictions that make it so that you're only authorizing the exact, strike or transaction that you wanted. And that's where there's some additional safety constraint. I think the perspective that people are having is if we make this opt-in so that not all transactions are by default subject to this, then it's kind of, buyer beware. You've made your own bed if you opt into a transaction using this, and there's no issue after that point.
Okay. So I think the summary for SIG-hash no input, there's some really promising user experience wins in Lightning and Layer 2. There are, as we don't want a nuclear attack, so there's a little bit more buttoning down to make sure it's safe to add. Let's switch gears to the last proposal that we wanted to talk about today. Jeremy, can you speak to, you proposed a few weeks ago, or last month, secure the bag. So let's talk about secure the bag.
So the idea behind secure the bag is kind of in the same mind space as what no input is trying to do. Can we make Bitcoin transactions more flexible for various scripting cases? For a long time, people have been trying to get something called covenants into Bitcoin, and they've been relatively unpopular because they permit, sorts of these launch all the nukes type situations. And so people have been pretty resistant. And so what secure the bag is it's saying, I've come up with a small short list of like 3 to 5 applications that are going to be really impactful. And here is the minimum possible form of covenants that really cannot be used to cause some of these nuclear crises. Is this acceptable? And I think I won't make the consensus judgment. I think people are pretty comfortable with the restrictions that are placed on secure the bag, that it's not going to impose this system-wide risk. Now, what are these applications? So one of the ones that I'm most excited about is transaction scalability. Right now, when you send somebody money, they immediately receive it, and they're immediately able to spend it to somebody else. Immediately meaning as soon as it's confirmed in a block. However, in a lot of cases, you just want to move your money off of the exchange. You don't actually need to spend it right away. Maybe you're managing your cash flow. And so what Secure the Bag lets you do is it allows, let's say, an exchange like Binance or Coinbase to sum up all of their users are trying to pay out and put them into a single output. And so the transaction size is significantly compressed. Once they've done that, every user knows that they've received the money. It's like a certified check. If you get that from somebody, you know that they can go to the bank and they can get the money out. They're not worried about that check bouncing. It's a similar concept. And what this does is this makes it easier at peak demands to issue transactions to your users. You can imagine if you're a company trying to pay out 10,000 workers at the same time and you don't make payroll, then you might incur significant legal expenses as your workers might sue for their compensation. So something like Secure the Bag allows you to pay a large number of people more scalably. One of the other use cases that is really exciting is around vaults. So vaults are a way of storing coins more securely that you can implement certain controls and procedures not just as business logic on your server, but actually tied to the exact coin that you have. So you can set it up such that your exchange cold wallet can only actually send up to, let's say, 10 Bitcoin per hour out to users unless there's a higher order intervention from executive staff. And that's one of the other major applications that Secure the Bag is going to move us towards being able to do.
Thank you. Just looking at the time, I think one question the audience probably has is when. Like, when can we expect these things in Bitcoin to be activated? So, Matt, maybe you can speak a little bit to like next steps in general for these proposals and what needs to happen.
Right, so, I mean, of the things we just discussed, Schnorr Taproot is the furthest along. It has a concrete, specific proposal. It's still missing a kind of clean, upstreamable implementation. It's got an implementation that's just kind of a sample demo thing, but there's not something that is kind of ready to go. So it's missing an implementation, but it's also missing deployment parameters. So that means, how is this going to be activated? And I think that's probably one of the more interesting questions from a community point of view. That's less a development question and more a community feedback question, is how should future soft forks be activated, BIP 9, BIP 7, BIP whatever. I think there's discussion to be had there. It's probably a few-month process just to have discussion around that. It hasn't started significantly in earnest yet, but probably over the next few months we'll see a little bit more active discussion there. And then from there, of course, it's an implementation question, getting it reviewed, and community consensus and feedback, and that's another few-month process, and then merged and shipped is another few-month process, and then actually activated is probably another few-month process. So I don't know, anywhere from 3 weeks from now to 2 years from now.
Yeah, somewhere in that range.
Somewhere,
So 2020 probably.
Yeah, optimistically, 2020 maybe people, kind of like get through the review, the testing, everything else like that. And also, like, typically we deploy it on a testnet first. So we have like testnet, which is kind of like a fake Bitcoin chain. Once we have it on the testnet, we can kind of like see it actually works well. We have to do the main activation. But like he's saying, the main question is kind of like, how is it activated? And maybe a few years ago, there was kind of like some contention around the prior activation mechanism, like, the miner signal for it. Do we just upgrade anyway? So I think there'll be kind of like maybe a hybrid approach, but I guess we'll see what people are comfortable with and see like kind of how the community wants to coordinate to actually activate these things in the future.
I think also one thing that's important to understand is that each of these proposals are, if you're not looking under the technical covers, they all, like maybe seem like they're just like how long it takes, but they have varying levels of complexity and risk in their design that maybe make certain things take longer than others. So I would think that given that there's like a much larger design space for no input, it might take more time for the community to decide what are the exact set of trade-offs that we want to make that are going to make this both usable in all the use cases we want, but also safe so that we don't have this nuclear crisis. Something like Taproot is relatively well designed and well thought out, but there's a pretty big design space as well, and so there's also maybe some additional time that it takes for something like that to reach full community consensus that this is exactly the API we want. And even for Secure the Bag, which I would, and you can disagree, I think it's maybe the simplest in terms of what what the design space is. There's still a lot of choices in how you do it, and different designs. And I think getting the community more broadly, not just the core developers saying like, oh yeah, this seems good. It's really going to be a discussion among the people who are going to build the applications on top of it to figure out, is this actually meeting demand? And that's something that I think is important to bring up, because I think sitting in the audience, you may be asking, how do I accelerate this process? I think by spending the time to learn, and Steve has really good resources through his OpTech newsletter, spending the time to learn how these things are actually implemented and working and how it might impact your business is going to do something, if you can advocate in the community, that will accelerate the eventual acceptance of these technologies.
Definitely. Great. I think we have around 3 minutes left. We'd love to take audience questions if there are any. I think someone has
Is there something called testnet hell for Bitcoin? And if so, how is that relative to like getting through to the main?
Oh, wow, that's like really OG. So like testnet L is something like Taj and I made back in like 2015 for like to test no input, like the very early version no input. It was kind of like a thing where we had experiments to try to test it out, but then eventually testnet like SegNet came out for SegNet. We used that instead. So testnet L was an old thing. The L was for Lightning, but doesn't like it's a brand somewhere on my computer. It doesn't really exist anymore. But yeah, that's like some like old trivia. That's like.
So I have a few questions from the app that I would love to ask you guys. So the first one, interesting question, does it matter if Bitcoin grows but without people who believe in self-sovereignty? So does that pose a risk to decentralization is a question.
That if people don't care about self-sovereignty?
Yeah, if it grows beyond the type of people who care about that, is that going to be a risk to decentralization?
Yeah, I mean, I think clearly it matters a lot that Bitcoin has a community of people who care deeply about not necessarily directly self-sovereignty, right? It's up to people whether or not they control their keys, but who care deeply about the way Bitcoin is structured and the way changes happen and the way the system is I hate this word, but quote unquote governed, and the way the system operates. It's critical that the community kind of self-enforces that. And so, as the community grows, we need more Bitcoin historians, we need more sharing of the things we've learned through the fork wars, through SegWit2x, and through all of these things that have happened in the past. And we need that to be deeply held as part of the value of Bitcoin, of those who are very active in the community. But of course, there will always be a vast majority of users who use the system who could not care less about, who care about the underlying properties, but don't care about enforcing those. And so it's about ensuring that there are enough people who care deeply about the underlying properties and who are aware of how those properties arise that can instill those beliefs, even if that's not kind of a day-to-day concern of the vast majority of users.
So I'd actually add to that. I think it's really important that we focus on making sure the user experience around self-sovereignty is as good as possible, and we minimize the gap between those solutions and custodial solutions. I think it's inevitable there's going to continue to be custodial solutions, and that's fine. But we just need to make sure that for users of Bitcoin who want to be self-sovereign, that they have reasonable user experiences for that. Right.
So that idea that culture is really important leads me on to the next question, which is how do you convince regular people who don't necessarily understand code to trust that and trust these people who are talking about self-sovereignty as opposed to politicians who are perhaps saying the opposite?
I think maybe an interesting thing to look at is the adoption of HTTPS on the internet, where there's a pretty, let's say nerdy, reason why you want to have this, and a lot of people might not understand what's so important about it. But I think by having kind of, cooperation between the nerds who, really, really care about these things and businesses, convincing them that this is actually going to de-risk their business, I think that that's where users can kind of seamlessly migrate onto this stuff, even if they're not aware of it, immediately.
Well, thank you so much. This has been great.
Okay, cool. Okay.